assistant professor in Ajay Kumar Garg Engineering College. So in today's video lecture, this is my second video lecture on subject software engineering, where I'll be discussing different software development life cycle models and on what basis these models must be selected. So first of all, it is used to facilitate the development of large software products in a systematic, well-defined and cost-effective manner. All these are the terms used that is very important in from point of view of a user and as well as organization and developer. It is the period of time that starts when a software product is conceived and end when the product is no longer available for use. Purpose of Sdlc is it helps to understand entire process, enforce a structured approach to development, enables planning of resources in advance, enables subsequent controls of them, and management to track progress of the system. Sdlc can be decided minimum 5 and maximum 9 phases. These phases identified along with entry and exit criteria. So Sdlc includes the following phases. First one is your project initiation and planning, recognition of needs, preliminary investigations and all. Second is your project identification and selection, feasibility study, which includes different feasibility, organizational, economic, technical, operational. Third is your project analysis. Fourth is your system design, which includes output, input, file, processing, detailed system documentation along with it. Next is your coding is done. After coding, testing will be done. In testing, we have this unit testing, that testing of each module isolated from other modules. System testing, alpha testing includes it is performed by development team. Beta testing, it is through the customer, it is done by the customer. Acceptance testing, it is also performed by the customer himself. Next, implementation, and at last, maintenance. Corrective maintenance, adaptive maintenance, perfective, preventive and all. Right. So maintenance phase requires maximum 60% of the effort. In development phase, integration and system testing requires maximum efforts, as you can see. Right. And maintenance is just 60% of your effort goes in this particular phase. So the first one is your waterfall model. It is proposed in early 70s and widely used even today, based strongly on the way hardware systems are designed and implemented. A model of software development process in which the constituent and installation are performed in a linear order. There is a single pass through each phase. Overlap between these phases is neither precluded or mandated. There is little or no iterative development. Then sometimes it is called systematic sequential approach. So here you can see different phases of a particular waterfall model. First one is your feasibility study is done, whether the requirements given by the customer are feasible to implement, or we have all the resources to implement these, or we have the knowledge or skilled developers for that particular technology. All these studies is done in feasibility study phase. Next is your requirement analysis. In this phase, requirements are analyzed based on different aspects. Next is system designing, then coding, then testing, delivery and operation maintenance. So all these are the different phases in a particular waterfall model. Advantage of this particular model is it is way easy to understand even by non-technical person, that is your customer. Each phase has well-defined inputs and output. For example, input to a system design stage is the requirement specification document, your SR document, and the output is your design document. It is easy to use as software development proceeds. Each stage has well-defined manager deliverables or milestones. It helps the project in proper planning of the project. Some of the disadvantages are it is in real time, it is very difficult to define all the requirements at the beginning of a particular project. In some cases, you can do that, but most of the cases, the requirements are changing, or sometimes the customer doesn't know what does it wants. So all these are the drawbacks of this particular model, where you cannot use this model. This model is not suitable for accommodating any changes. It involves heavy documentation. We cannot go in the backward direction while Sdlc performs. The model is not suitable for new projects because uncertainty in the specifications are there. Next model is your prototype model. It is a partially developed product. A prototype is nothing but a part or a subset of your final product with some one or two functionality, right? It is a process of developing working replica of your system. It always happens that a customer defines a set of general objectives for a software, but does not identify detailed inputs, processing, or output requirements. In other words, the developer may be unsure of the efficiency of an algorithm, adaptability of the OS, or the form of human or machine interaction should take, user interface basically. The prototyping begins with the communication. Here the developer and the customer meet and define all overall objectives for the software, identify whatever requirements are known, and outline area where further definitions are made. A quick design then occurs or made by the developers. The quick design focuses on the representation of those aspects of the software that will be visible to the customer or the user. These, for example, input approaches and the output format. So here you can see this is the idea here. First, requirements are gathered through customer. Then a quick design is made. Quick designing is done. After designing, a prototype is built. Then it is given to the customer for feedback. If the customer finalizes the prototype, then the remaining phases are done as you studied in waterfall model. But if the customer is not satisfied, then some suggestions is given by the customer to the developer team. Then all the requirements that have gathered or documented in SRS are refined. And then again quick design is done, and this cycle goes on. Reasons for using prototype model. So, important purpose is to illustrate the input data formats, messages, reports, and interactive dialogues to the customer. This is valuable for gaining better understanding of the customer's need. The prototype model is very useful in developing the GUI part of the system. The prototype model can be used when the technical solutions are unclear to the development team. Often major design decisions depend on an issue like response time of a hardware controller or the efficiency of the sorting algorithm and all these. Third reason for developing a prototype is that it is impossible to get it right the first time, and one must plan to throw away the first product in order to develop a good product later. So, few advantages of prototyping model is it is suitable for large system for which there is no manual or process to define the requirements. User training to use the system. User service determinations. System training requirement are not freezed. So in all of these cases, this particular model is really good to be selected. So, limitations of prototyping model is it was very difficult to find all the requirements of the software initially, because a prototype is built initially. So, all the requirements are cannot be implemented at the very first prototype also, right? So, we need to prioritize the requirements and give only 2-3 requirements or fulfill 2-3 requirements based on the customer perspective, right? And then deliver the prototype. It is very difficult to predict how the system will be after the development, right? So this model lacks here. Next is a iterative enhancement model. It applies linear sequence in a staggered fashion as calendar time progresses. Each linear sequence produces deliverable increments of the software. For example, word processing software developed using the incremental paradigm might deliver basic file management, editing, documentation, production function in the first increment. Then more sophisticated editing and document production capabilities in the second increment. And then third increment will include spelling or grammar checking maybe. And the fourth increment can have advanced page layout capabilities, right? So these are the product is given by different increments. It should be noted that process flow for any increment may incorporate the prototyping paradigm. So here you can see, firstly, requirements are defined, then assign requirements to each increment. Which requirement is to be given first in the first increment, then in the second increment what requirements needs to be implemented, and so on. Design system architecture, this is same as waterfall or earlier. Develop system increment. Firstly, the system increment is validated through SRS and by the customer. Integrate increment and then validate system, right? So here you have this again. When we validate system, if then again develop the second increment, validate in it. This cycle goes on up till the final system is developed. So when an incremental model is used, the first increment is often a core product. That is, basic requirements are addressed, but many supplementary features, some known or some other unknown, remain undelivered. The core product is used by the customer. As a result of use or evaluation, a plan is developed for next increment. The plan addresses the modification of the core product to better meet the need of the customer and the delivery of the additional feature and functionality. This process is repeated following the delivery of each increment until the complete product is produced. So some of the advantages of this particular model is the feedbacks from early increments improve the later stages. User get benefit earlier than with the conventional approach because you have this particular increment or working model of your system. Early delivery of some useful component improves cash flow because you get the customer will get the feel of the product initially. Some return on investment early on. Smaller sub-projects are easier to control and manage. Now moving on to the disadvantage of this particular model, software breakage. Later increments may require modification to earlier increments. This can also be happening. Programmer may be more productive on one large system than on series of smaller ones. Some problems are difficult to divide into functional units or modules which can be incrementally developed and delivered. So moving on to the next model, which is spiral model, right? It is an evolutionary software process model that couples the iterative nature of prototyping with the controlled and systematic aspects of the waterfall model. It provides the potential for rapid development of increasingly more complete versions of the software. The spiral model is a realistic approach to the development of large-scale systems and software. The spiral development model is a risk-driven process model generator that is used to guide multi-stakeholder concurrent engineering of the software-intensive system. So here the core difference between this model and the other models are this particular term, risk-driven. In this particular model, risk analysis is done, right? The risk on the basis of the percentage of error, failure, right? We have calculated, or what is the ratio that this particular software is delivered successfully. So that will be calculated in the early phase. So task set. In this model, each of the regions with the set of work tasks is called a task set. The size of system set will vary according to the project. Task region is a region where set of tasks is achieved. Principle of spiral model. It elaborates software entity object and find out constraints and alternatives. Elaborate definition of the software entity for the project. Software model, spiral model terminates a project if it is too risky, right? Or if the costing of the particular project just overflowed from the actual costing given by the customer, right? So in that case, a company will definitely do not go with the project. So all these are the tasks that needs to be done in parallel model. Firstly, the customer communication task requires establishing effective communication between the developer and the customer. Next, planning task requires defining resources, time, and other related information. Next is risk information. This task requires to access both technical and management risk. Engineering task require building one or more representation of the application. Next, construction and release. The task requires constructing the project and releasing the project to the customer. Next, customer evaluation. Task required obtaining customer feedback based on evolution of software representation created during the installation stage. So here you can see the model. So this model starts from this particular phase. This is the first phase. Then comes second. All these are regions basically, and different phases are divided in those regions. So firstly, we have determine objective, alternative constraint, obtain commitment, etc. Then this cycle goes on, right? We develop a prototype and all. Then concept is made, life cycle plan is decided. Then risk analysis is done. Again, all these, this goes on in a spiral. All these, see, you can see testing, all type of testing in this third phase, right? Where you are developing the product, because product design and this, and then you are testing, right? Integrate, test plans, development, all the planning is done here, right? Then risk analysis at each cycle is done, right? So this is how a spiral model works. Moving on to the advantages, user will be able to see the project development cycle, how the project will be developed, right? Risk analysis, which resolves higher priority errors. Project is very much refined, reusability of the software, all these are the advantages. Next, the disadvantages, it is only suitable for large size projects, because in small size projects, the more spiral will only create the extension of time, effort in terms of the developer rather than the customer. Model is more complex to use. Management skill is necessary so as to analyze the risk factor. Without knowledge, proper knowledge, you cannot analyze this factor. Thank you.